Hello team, my name is Mahesh. In this video, we are understanding about the Docker and the Docker Swarm and the Kubernetes itself. In this video, we are deep diving into the architecture of the Swarm and the Docker Kubernetes architecture itself. We'll look what are the key differences between them, how we can install both of them and connect to worker nodes with it, how we can manage, and what are the key differences between them. uh, we'll look what are the advantages and disadvantages of using the Swarm itself, and many more things will be covered in this video itself. So, Docker Swarm is a Docker native clustering and orchestration tool. It allows to run pool of Docker host into single virtual Docker host itself, and Swarm makes easier to deploy, manage, and scale your containers across multiple Docker hosts. Uh, setting up Docker Swarm, it's very straightforward process. You need to initialize Docker Swarm on the master node itself, and once your master node is up, you can connect your master node throughout the Docker Swarm join. With this token itself, you can join your Docker master to your Docker Swarm worker itself. You can initialize Swarm and join nodes and then deploy services. Swarm can handle load balancing, service discovery, and scaling and desired capacity reconciliation. All those things are already managed inside a Docker Swarm itself. So Docker Swarm has some highlighting features. It is a quite simple to use. If in compares with the K3s model itself, it is quite simple in installation. It will integrate with the Docker CLI itself. We don't need to provide any extra things. It supports service discovery. What does it mean? Automatically assigns IP address to the services, load balance between them. If you have multiple nodes, as you can see over here in this container section, I have three nodes right now. So it will automatically scale if you have multiple requests simultaneously or concurrently, we can say. It will provide a scaling also. It will automatically scale up and scale down as it will require, and rolling updates. The Docker Swarm has a like Docker Swarm has a rolling update services without downtime. Swarm ensures zero downtime by incrementally updating the services without taking a downtime. Docker Swarm can incrementally add the nodes, and it will reduce the downtime process. So let's look real world example. Imagine how small, medium sized application and few services with Swarm simplicity make a use of a perfect managing such application without overhead. So I have one application over here. This is a simple voting application. We are deploying this application with the Docker Swarm itself. So I have a master node over here. So inside a master node, what I can do, I can just copy and paste this repository with the git clone, and it is fairly simple. It will fairly simple than this architecture itself. In the Kubernetes, such people in IT person itself, it is quite complicated to managing and configuring all those services, such as it has uh, it has services inside the master node. It has inside services or components of the worker node itself. Throughout the API, it will connect with each other. So all those things are quite hectic to manage, such as the namespace, the ingress controllers, the load balancers, the service types, the service discovery. All those things are quite complicated when we are dealing with the Kubernetes itself. So in such cases, the Docker Swarm is quite good. Docker Swarm is quite good option for us. So let's go over. If we can see that the Docker Compose, I have a services that are already written by the developer itself. So it is a voting application we are building, and if we are running this particularly bash script itself. If we are also performing the health check, if the local host is reachable through the curl command or not. If we getting timeout, it will restart the container again. So in the results itself, we it has multiple containers that it will create, and throughout this container itself, it can it can, let's look how we can install this inside this inside the repository itself. We can get Docker Swarm in it. What it can do, it will generate an environment for us, Docker Swarm in it. Swarm SWARM. Okay, the Docker Swarm, when it is already there, what we can do, we can deploy our stack with the compose file. Uh, we have a command Docker stack deploy stack.yaml. What will create a services for us. It will create a it is creating a few services such as those two network services. Few are the services with the DB related services, and all those things are it will create. So after that after that we can access our application directly with the directly on the particular port itself. Once it will create once it will create an services we it once it will create an it will build and create an application. It will create an pods. After that we can access our application on the browser itself. So while there are some advantages over the using the K3s model and using the Kubernetes itself. It is with for what people why people are using Kubernetes itself, because it provides a auto scaling, it provides a auto healing, it also it can automatically scale up and scale down the instances. It has several components with the master node and the client worker node itself, such as the master node has components with like API server, the scheduler, etcd, again the etcd, and like control manager, cloud control manager. All those things are inside the master node itself. It has also it will Kubernetes will also support the uh, like um, high level networking, such as it will support the of Flannel Calico networks, and it is better basically authentication mechanisms that advanced authentication mechanism that Kubernetes will support. So look, it is creating few services that we need. If we can refresh this, and it will create it is creating a ready it will create a Redis. It is creating a Postgres database. It is creating the voting application from it will fetching the application from somewhere, and it will create. So Docker P, if you see inside Docker PS itself, it has created a uh, Postgres itself for now. Docker services ls, Docker service ls, not services, sorry. Yeah. Inside this, we can if you can see what DB has already created is as a one replica, uh, such as the radius and the result. All those replicas are creating for now. Once this thing is done, we can access our application inside with the port 80 itself, on our application itself. So let's wait for some time, and it will create a container for us. So this is how the the application works. This is how our things work, and we are same deploying this application on the KTest itself also. So we are using the Docker compose.yaml file, such for deploying the services, deploying the we can so deploying such services. We need to write it on over here inside the services section, inside the results. We have a specific part that inside this compose.yaml file that we have used to initiate the swarm. Inside this, we have independent services such as the services. We have a application that is running on port 5000 on the container side and the port 80 on the client side, and it will require those two network itself. Inside the results, result will also connect to the those two networks. It is working on port 5001, and it depends on a DB connection. We have a connect we have a result container is run. We have a worker container that is doing some another configuration. We have a DB that once the DB is ready, it will connect to the result section itself, because it's depend on this, and all those things are written docker.yaml file, such as on the K3s or K8s Kubernetes service itself. We need to provide a pod specification.yaml, or such as you can see over here. Let me increase the font for you. Appearances 14. Yeah. Okay. Yeah. Inside this, we have a ex- get service. Inside this, we have one service which will access on port 443, but it doesn't have an external IP address. With the cluster IP address, we can access the service itself throughout the Docker from the K3s kubectl cube nodes. With this, we can get the nodes which are the connected with the our particular rules itself. We're not deep diving in this, but throughout this we can get that. So our application is running, I guess. So let's check on our over here, Docker services ls, Docker service ls. You look, our application is running. Let's access this IP address on the fconfig, and our virtual machine IP address is, so virtual machine, this one, 192.168.1.132. So let's access it on browser itself, colon 80. Okay, the application which is accessing on port 5000 itself, which is running perfectly right now. Inside the results, we can get the results, I guess. Results, not the reset. Re, oh, no, it's inside the result. There is nothing. So not an issue. Our This application is running on the particularly our Docker Swarm itself, and um, yeah, throughout the Docker Swarm, it will throughout the Docker Swarm, it will automatically replicate multiple instances as we require. Update of the docker.compose, this particularly YAML file. Once we upgrade the and once we it will update the replica, that update the replica as we need to run our application itself. Inside this, if you can see, doc we have a multiple replicas over here, such as we are if you hit this, and we can, if we run this again, automatically says that we need more replicas, and it will automatically reconcile to the desired replicas. So now what we need to do, we can also try to deploy this application with the Kubernetes itself. And what we can do, I can go on my Kubernetes server, and in this what we need to do, we need to uh, clone this particular repository itself, git clone, and once we inside this we have a or such as it has a deployment. We need an app. It will connect to the Postgres. It will connect. We need to set up the environment itself. All those things are all those things are mentioned on the particular YAML file itself. Throughout the Yes, this particular kubectl command ctl hyphen f hyphen f ks specific. Okay, we need to leave this. We need to run this command over here, and what we can do, uh, k3s kubectl create hyphen f, and we are providing our KTS files itself. So it has basically YAML files, and throughout this it will deploy our containers, deploy our pods itself. So inside this, what we can do, kubectl get pods. It is running the pods. It is not. It has been not. It is not ready yet. It will once it ready. We can get the status. So kubectl get pods and kubectl get nodes. uh, get nodes. We have only one node right now, and kubectl get services. Inside this, we can check the running services. So inside this, each cluster have a specific internal IP, but it doesn't have an external IP address. So if anyone can access this particular Kubernetes cluster itself, it has access to this particular containers itself. So kubectl get nodes. This will not work. Kubectl gets pod. Throughout this, we can see the pod is ready or not. It will might take some time uh, to deploy the pods, and once this thing is done, we can access our application on the port 3000, port 5000. So there is we can access port 5000, and our result will be port 5001. So we have we have a one board, and the board is totally on logs itself. So it is quite simple application that will have a it will running on port. It will running on Docker Swarm itself, and we are running another application. We are running same application on the Kubernetes itself. So our Redis is running. Let's wait for some time. It will take some time to run all those content, all those worker, all those nodes. So let's say we have a services for the ingress control or something. Uh, we have a DB service, we worker deployment.yaml, and how we can access this worker deployment.yaml. Uh, so let's wait for some time. Check if this this working or not. Kubernetes kubectl get nodes inside this, get pods. All the pods are running. Okay, cool. So now we can try to access our pods with the particular IP itself, and we can access IP space A kubectl get services inside this particular inside the port itself. We can access the service. So for port, we have this IP address, and port 5000 colon 5000. We can access our service with this particular IP. Let's try 5000. So this okay failed. Okay, look, we have an option to submit. We have option to it is loading the page basically, but it will not. It doesn't have access to external IP addresses or IP addresses or something. So it will not able to be not able to access with outside itself. So as you can see, it is loading the page, and if I go and it's a results page itself, it is working fine. But we haven't proceed any results for now. We haven't select any type. It will not showing anything out as such output for us. So this is how our application is running, and one application is running on port. One application is running over here on the we have a multiple replicas. We can just scale it by like 10. And once we do that, it will automatically scale up for us. As you can see over here inside this particularly Docker service ls. Inside this, we it will automatically replicating to our desired state. It has already 5 replicas. What we can do, we can upgrade our uh, this will automatically scale up and scale down the instances as we need. We can see which are the things are running over here and which what are the particular services for the DB, what are the results that are proceeded over here. We can see the overall logs for it, and all those things are I'm able to monitor with the container itself. So this is how the application is working. Inside this Kubernetes itself, we have a lot more options and lot more configurations to do. We can simply by this small script, we can get the Kubernetes version, one version, which is the cubes, which is this K3s model itself, and we can work with this. So now let's talk about the Kubernetes itself, often abbreviated as a K8s in open source platform originally developed by the Google. It is a Kubernetes is a small part of a Borg itself, and it is designed to automate the deployment and scaling and operating application on containers. Kubernetes is also known for its robustness and features to ability to handle complex and larger scale environments. Kubernetes organizes containers into pods, smallest deployment, which are the smallest deployments basically, and smallest deployment units. Pods can contain one or more containers, and it can scheduled upon we can and it can schedule on nodes itself. The Kubernetes control plane consists of components such as the API server, the API server, kube proxy, controller manager, the scheduler, ensures the desired states of the Kubernetes master node itself, or the Kubernetes architecture overall. So cluster itself. So it has some key components such as it can automate the rollback and the rollouts. It can automatically roll out changes on your application and roll back to the previous version if something goes wrong. Uh, with this, uh, uh, let me show it. Uh, Let me show it to you. Mm. So it will auto supports the self healing. It if the some containers get if some container get fail, it will automatically replicate. So get get nodes, get pods. If you can see for here, if some container goes down, it will automatically restart the failed containers and reschedule the container if some container are died or killed. So it is also supports the horizontal scaling, scale up your application on multiple nodes. With this, it will provide the highest availability on the machines itself. It will also provide the secrets manager to configure keys, the specific access keys or something, or tokens. The advanced networking capabilities will support. So Kubernetes have some added advantage over here. So uh, for the for using small scale environment itself, Kubernetes is quite hard to quite complex in nature. Kubernetes has complex, powerful, and suitable for large scale production grade applications. Docker Swarm is simpler to use in ideal small projects for teams. Uh, Features Kubernetes offers advanced features such as automatically rollouts and rollback, self-healing, horizontal scaling. Docker Swarm provides the essential orchestration features such as such as orchestration features, but it has some lacks. And Kubernetes have advanced capabilities with this right now. So it has on each other's perspective. The Kubernetes is working as Kubernetes has working as an enterprise for larger scale deployments, and if you are running lower scale deployments, you can work with the Kubernetes Swarm itself. So that's it for all.